By the end of this video, you should be able to define tangent to a circle and also use the theorem we're going to be discussing in this video to solve certain problems. So how do we define the tangent of a circle? So a tangent is a straight line that touches either a curve, looking at a parabola, or a circle. So let's say that we are taking this as a curve, a simple parabola, and then we have a straight line that touches this curve, right? This straight line is referred to as a tangent, and to be more specific, we can refer to this as a tangent to a curve. The same thing goes with this. If you have a line that touches the circle, we refer to this as tangent to a circle, which is the subject of what we are learning in this video. Now, by definition, we can say that a tangent to a circle is a straight line which touches a circle externally at one point only. So we can draw as many tangents as possible on these two circles. We can have one at the top here. This is a tangent. We can have another one right at the bottom here. This is another tangent. We can have one on the side. We can have another on the side. This is a tangent. This is a tangent, right? Because they touch the circle externally and they do that only at one point. So these are the points. So this is one point. This is one point of contact. This is another point of contact. And this is another point of contact, right? So let's look at the theorem that pertains to this. So I'm going to read out the theorem and interpret what the theorem is saying for you. The theorem says that the straight line which is drawn at right angle to the radius of a circle at its point of contact is a tangent to the circle. So what they are saying is this: if you have a radius, right, of a circle, and you have a line, and this line happens to touch this radius at the point of contact with the circle, the angle between them is right angle. So this line is a tangent. This is the radius, and the angle between them is 90. So they are perpendicular. So a radius and a tangent to a circle at the point of contact, they are perpendicular to one another. So which means that the angle here is equal to 90 degrees. Now let's look at how this theorem can be applied in solving problems like this. In the diagram, O is the center of the circle, just like we've seen. QR is a tangent. QR is a tangent to the circle at Q, which is the point of contact. Then SOQ is 86. Find the value of SQR. So I am to find the value of SQR, which is the angle I'm going to mark here. So I'm going to call this angle X. Now remember that our theorem says that the angle between the radius and the point of contact of a tangent is 90. So which means that angle OQR is equal to 90 degrees. Now I'm going to call the remaining angle that you have here, which is inside of the triangle, Y. Remember that both X and Y sum up to 90 degrees. So I can say that X plus Y is equal to 90 degrees. So we are coming to that. Now back to the triangle. If you check the triangle very well, the triangle which is the one that we have inside the circle, you're going to see that it is an isosceles triangle. The reason is because the line OQ and the line OS are basically the same. O to Q, that's the radius, and then O to S is also radius. So because it's running from the center to the circumference, that's just the basic explanation to that. And that makes triangle OSQ, or triangle, anyhow you want to call the triangle, right, an isosceles triangle. So if I bring out this triangle, I have it this way. I have 86 degrees. Here I have Y. So automatically this place is going to be Y as well. Isosceles triangle. So how do we find Y? This is sum of angle in a triangle. So we say Y plus 86 degrees is equal to 180 degrees. So when you solve that, you have 2Y is equal to 94 degrees. So Y equals 47 degrees. So which means that the angle here is 47 degrees. And the one here is also 47 degrees. How do we find x? Recall here that we said that x plus y is equal to 90 degrees. These are complementary angles. So we can say that x is equal to 90 minus y by making x the subject of the formula. So we have 90 degrees minus 47 degrees. That is equal to 43 degrees. So we can say that angle SQR is equal to 43 degrees. And the second problem, we still have the same thing showing up. We have a tangent, we have radius OT, we have a point of contact at T. But this time around, we're expected to calculate the angle PTN, which is the whole of the angle here, from here to here. This is what we are trying to look for. But before that, we can easily identify certain things based on the theorem we've learned. That angle PTO, the angle right here, is 90. Okay, so let's just put that down. Angle PTO is equal to 90. The reason is because the perpendicularity you have between the radius and the tangent. Moving on. Now, is it possible for us to find the angle here? Because the reason is because if we are able to sum up the angle obtained here and the one here together, then we have angle PTN, which is required of us. Now, the angle here, which is angle OTN, is inside a triangle, which is very similar to the one we had in our previous problem. So if I try to extract out the triangle, okay, and here we have 108 degrees. Here, well, we don't know. That's what we're looking for. T, O, then we have N right here. And here also is unknown. Remember that ON and OT are equal in length. They are radii, right? So which makes them equal from that point of view. So if I call this Y for now, then by the way we've been calculating it back and forth, then we can say that 2y is equal to 180 degrees minus 108 degrees. So that y is equal to 72 degrees divided by 2. And that makes 36 degrees. So which means that the angle here is going to be 36 degrees and the one here is also going to be 36 degrees. Remember that we have to sum up the angle here, which is 90, and the angle here, which is 36 together, to have the angle PTN we are talking about. So to put that into a better perspective, we can say that angle PTN is equal to angle PTO plus angle OTN. So that is equal to 90 degrees plus 36 degrees. This is equal to 126 degrees. That's it.